the scores were higher for this first set of homework than they usually are for a first set of homework, so good for you. If you did not get a 30, take a look through and you should be able to figure out why. If you missed stamps, then I wrote stamp question mark. Most of you got most of the stamps though, which was awesome, so keep up with that. That's important because that's easy points, right? You just have to give it a shot every day. The other points, the other 3, one of them is just making sure it's all the way done, making sure that you've shown your work, making sure that I understand what happened. And then the other 2 points are actually looking at 2 questions and making sure that you did those and finished them correctly, okay? Writing down, we did it in class, is not doing physics, okay? So actually go through the reason we do them in class is to help you figure out how to do that, okay? So make sure when you hand homework in on the day of a test that everything is done and completed and correct. And if you have questions, I'm here before school, I'm here after school, come in and we can go through things one-on-one. That's totally fine. Or talk to somebody in the class or talk to somebody in Mrs. Cross's class. Figure it out, okay? You guys can do it. I know you can. Any questions on the homework that you got back? Yeah. It's entirely possible that yours was in the pile with the problem sets. And if it was, I haven't done the problem sets yet, so it may have gotten in that pile. Okay. So I'll look through, because when I do the problem sets, I'll probably find it. If it's not there, then I don't know where it is, so I'll have to find it. Yeah, yeah. Other homework questions? Looking at the labs. I have my student aide grade the labs, not this student aide, but a student aide that's not in your class, because that would be bad, right? That's like, ah. So it's somebody who is in my AP Physics class, has taken this class, knows what he's doing, and he does it like while I'm watching and answering questions for him. I trust him. I think he should be okay. But if you have any questions about why you missed points, please feel free to ask, okay? When I go through, usually we go through 2 or 3 together to make sure that he understands how to apply the rubric. I really, really stress, and I want to stress with you again, all of the points that are available on a lab are written on that rubric, right? So if you follow those instructions, labs should be full credit or nearly full credit every time. Does that make sense to everybody? Are there any general questions that you have about labs? Anything that I can answer? Yeah.
So if you get one of the lab questions the answer wrong, then you get points for it.
Correct. Because you should be able to answer them correctly. And you should feel free, I mean, seriously, friends, if you have a question or you're not sure, or even just want to make sure of something, talk to each other or ask me. I'm very happy to look at labs early. You know, you have that extra day in between when we do a lab and when it's due. The reason for that is because, I mean, we've talked about that a lot as a science department. It's so that you can work on it that first night, and I know that doesn't always happen, but you can make a point to make it happen, to do it that first day or, you know, one of those first 2 days. And then if you run into any questions or you want to verify, or you know what, honestly, if you just want me to look over it and just kind of give it a quick glance and say, yeah, this looks great, or, oh, you're missing blah, blah, blah piece, I'm very happy to do that. I'm not going to grade it twice, but I will look through it and make sure that everything's there if you want me to, okay? But you just have to ask for that. And did you have a question?
Yeah, so if you get your sig figs off, does that count as a full point being taken off?
So generally, it's just 1 point for the whole like lab or the whole test or whatever. Yeah, yeah. So you do want to pay attention to sig figs, but if you mess them up all the time, then it's not like you're doomed to get like a negative score or something like that. Yeah. Any other questions? What's that? Yeah, that would be really sad. That would make us all sad. We don't want that. Anything else? Last moment for that before we move on? Yeah.
How do you put these in the grade book?
They are not on Infinite Campus, but I'm hoping to get them in today after lunch. That's my goal.
Okay.
Yeah, yeah. Yeah.
So the answer to the lab question 1A is like 156.
I don't remember off the top of my head, but
Because I put 0.16 as sig bigs, but one of the sig bigs had only 2.
Let me look at it after we are working on other stuff, and I can take a look. Yeah. That may have been a miscommunication between myself and my grader. Anything else? Don't let me forget, though, because, yeah, just, like, leave it out so that we don't forget. Okay. All right. So last time we were together, we started talking about what? Do you remember?
Projectile motion.
Projectile motion, right? It's been a long time, I feel like, since I've seen you. I guess it was just Friday. It was just a long weekend maybe or something in my head. We talked about what? We did like this launchy stuff, huh? So we launched that ball bearing going this way. We had a ball bearing going straight down. What did we find out about their fall times?
The same.
Same time for both of them, right? So that x velocity, or the x motion and the y motion are completely independent of one another. And then I think we worked on a problem, the one from the bridge. Does that sound about familiar? Yeah. Okay. And just to and it looks like we finished that one. Is that right? Does that seem right? Okay. And so then maybe we started another question, and I just want to get our brains back into this, but I don't want to just throw you in cold, so I want to just remind you a little bit about setting this up. Every time you do a projectile motion problem, you want to set up your x column, your y column, and t is the thing that ties it all together. This equation, if you haven't started loving it yet, it's time, okay? It may not have bought you chocolates and roses for Valentine's Day, but it really is, it is your equation of choice to solve these problems, okay? What I'd like you to do right now is open your book. We're going to work on a couple of problems. Would you like to do one together first to get our brains moving? Would that be helpful? Okay, let's turn to page 102, and let's find a problem to work on. Did people start question 1? I can't remember. You did start it. So let's go ahead and do that one together. Does that sound okay? So page 102, question 1. And to get the blood flowing back in your brain and the blood flowing back in your fingers, I want you to take a look at that question, set up your givens list, draw your picture, and then we'll regroup in just a moment so that we can double check and do the problem. Sound okay? Okay, talk to each other, read it together, do it. All right, can we work together to put our givens in? Does that sound okay? Raise your hand if you can tell me a given. Go.
D for x is 0.25 meters.
Everybody okay with that one? Does that make sense? It says it strikes it 0.25 meters away from the base of the desk. So if you draw your picture out, this is obviously not drawn to scale, but it gives us something. That tells you UDX. Absolutely. What else you got? What's another given? Something else you know. Go.
Acceleration for x is 0.
It is. Every time, always, right? Yes, that is a given all the time, except for there's one question you'll do in chapter 4 where it's not true. But for right now, chapter 3, always going to be 0. What else do you know? Something else. Rowan, you got something?
Acceleration for y is -9.81
You got it. Negative 9.81 what?
meters per second squared.
Yeah, nice. Go.
The displacement of y is negative 0.70 meters
Why is it negative?
because it's falling down.
Is that okay with everybody? Does everybody catch that negative sign? Most of the time, friends, dy is going to be negative. Most of the time. All right, there are 3 things that don't have any numbers in them. I think maybe one more of them should have something written down. Any ideas which one? Go.
velocity initial of y is 0?
Velocity initial y is 0. Why?
Because it's not going anywhere down.
Yeah. And that it helps to draw that arrow. Does that make sense? Because secret, soon that's not going to be the case. So make sure that you draw that arrow right now so that you know that that's going to be 0. Meters per second. What is it that we are actually looking for in this problem? The speed in the x. It wanted to know, it said how fast was it rolling? It's only rolling in the x direction. So that has to be the one that we're looking for. Any ideas what we're going to do first in order to solve that problem? Jake? Oh, I'm sorry. Yeah, go ahead.
Find time.
Find time. How are we going to find the time?
By using an equation.
Time! Where are you? What?
You have to use an equation and plug it in.
Plug it in. An equation, any choices anybody wants to pick for equations? Thinking about D, V, I, A, and T?
The big one.
The awesome one, right?
Yeah.
The one we love. Yes. dy equals vyt plus 1/2. Is everybody kind of okay with this? Are we doing okay? Eh?
Kind of throwing me off, but I get it.
What did I throw off?
No, the D.
Oh, the D instead of X? You can write this. It really is okay. If you want to write this as delta X and delta Y, that is totally fine. That will work for me. I'll understand it. I'm not going to count it wrong. It's all good. If that makes more sense to you. Yeah?
What if we write delta x with a little x underneath and delta x with a little y underneath?
If that makes sense to you, that's fine. It won't bother me. Just make sure that you have the little y there. Yeah. All right. Are you ready to go? Can you solve for time? Do it. Go, go, go. Help your team out. If you need to take 17 steps to solve for t, that's fine. If you're one of those crazy algebra whizzes that can just see it, that's fine. I need to see this equation, and then I need to see the expression for time. If you want to show me a bunch of steps in between, great. If not, that's okay too. All right, so once you've got an answer, check with your neighbors. See if their answer for time matches your answer for time. Have a conversation. Okay. We getting some stuff? Rosemary, what did you guys get over there for time? 0.3? Was it like 3 by itself, or was there more stuff to it?
0.3777.
Lots of 777s. Yeah, yeah. So the reason I ask, and the reason I want to point this out, a lot of people want to do sig figs right here. But the issue is that if you use sig figs right here, then you're losing information. Do you know what I mean? Every time you do sig figs, you're rounding, you're cutting off information. And is this what we actually want to know? Is this our final answer? No. So I want you to hold on to this number. You can write it out. So I write it out, 5 or 6 decimal places. Okay? Because you're going to then use that number to find the initial velocity. Using the same equation just with x's in it, right? Go ahead and do that next step. I'm going to come around and make sure people are doing okay. I'm going to write this out real quick first, though. Doing your calculations, instead of writing out each step, utilize the button that for most calculators exists right, like maybe on the minus sign or somewhere very near the equal sign that says ANS. Do you see a button? It might be second and then that button, right? ANS means answer, okay? So like right now I have my time is the last thing that I did. So I can use that right here. So I don't have to like do this approximation. Once I've done my algebra here, I can do 0.25 divided by second answer, and magically it remembers that number, and then no rounding has happened. Well, I mean, very little rounding has happened. And then the best or the closest possible answer will be there for you. Does that make sense?
Yeah.
If you need help finding that ANS button, let me know. I can help you find it. But it's not something you have to do. It just makes your life easier. We like to make our lives easier, right? What did you get for VX? 0.66?
Yeah.
Meters per second. How's this going? Is it making sense? Want one more practice? Should we do? Why don't you, I said one more practice, and this sounds kind of like I'm lying, but I'm not. Why don't you take a look at questions 3 and 4? They go together. So they're kind of like 2 separate problems about the same story. Number 3 will look very similar in process. Number 4 is a little different. I'm going to let you work. I'm going to write answers up here. So if you don't want to know the answers, then don't look up here. Is that fair? And then I'll come around and answer questions. Talk to each other as you're going through this. Again, we're doing numbers 3 and 4. Mostly I like it because it's about a pelican, right? We like the pelican problems. Poor little fish. They have such a hard time. They're so clumsy.
That pelican probably starved.
I know, right? okay to talk, I promise. Once you've got your givens, just check in with your neighbor and see if they agree. Do they have the same thing as you do? It's really nice to avoid errors that way. Noticed, as we went through the last three problems, that it's all the same question. Have you noticed that? It's the same problem with the same setup and the same equation every time. You're just plugging in different numbers, right? So it kind of gets routine and like it's really no big deal, which is part of the reason that when people say that projectile motion is really, really hard, kind of like, well, if you just set it up carefully, then you should be okay, right? Okay. There is one little hiccup that I do need to introduce to you, and that is kind of a reality check. Do you ever see projectiles in real life? Yeah? Give me an example of a time you see projectiles in real life. When do you see one in real life? Yeah?
When someone jumps off a diving board.
Somebody jumps off a diving board. Absolutely. Yes? Have you watched somebody jump off a diving board before? Yes, absolutely. What else?
Someone kicks a football.
Somebody kicks a football. Absolutely. Yes.
When you trip on something and you fall.
True statement, right? Like, whoa! Right? Absolutely. Yeah. Yeah. Other times you see projectile motion in real life. Oh, you look like you were going to say something. No? No? Anybody else? Yeah?
When something rolls off the table.
Something rolls off the table. This happens all the time, right? We actually skipped question number 2, and I was kind of sad because I like that question, mostly because I think it's funny. The cat chases a mouse across the table. The mouse steps out of the way and the cat slides across the table and boop, boop. Yeah, because my cat would totally do that, and I just think it's hilarious. So anyway, all of the problems that we've done so far are like things rolling off tables, right? Or, you know, some sort of like this thing. But if you've ever watched somebody jump off a diving board, how often do they roll off the diving board? Rarely, maybe some people, but generally, if you're watching like really legitimate divers, they don't do that, right? Where do they go first? Up. Right? If you've ever watched, I don't know, football or soccer or baseball or, I mean, pick a sport where there is an object flying through the air, right? Most of the time that things are flying through the air, they do not start off with a horizontal trajectory. Anybody in here play softball? Are there any softball players in here? One? Only one softball in the whole thing? Wow, baseball players? Or we have a few? Okay, we've got expert now. We've got a softball player and a baseball player. All right. 2 baseball players? No, just one. All right. So Anna, when you're playing softball, what position do you play?
I play outfield.
Outfield. Perfect. So she is, do you have a favorite position, a favorite spot?
Center.
Center field. Okay, so let's imagine Anna out there. Have you all seen baseball or softball? You can picture this. You've played it in you know, PE or whatever. Here's Anna. She's got her baseball or softball, and she's about to throw it in. Big hit. They need to, you know, get the ball in as fast as possible. Is she going to throw the ball like this?
Go ball. Get there.
No! Number one, her coach would probably be like, what were you doing? Right? Number two, it's only going to go a few feet in front of her, and then runs are going to score. It's going to be a horrible disaster. Right? Like, that doesn't happen. Anna, how do you actually throw the ball?
Up.
Right. If you draw the trajectory of what the ball does, it goes up and then it comes back down. Are you with me there? Okay. So that's a whole other realm of projectile motion. These problems that we've done so far, I like to divide them into different cases just because it kind of helps my brain. This is like a case 1 problem, a horizontal trajectory. Okay, it starts off horizontal. Case number 2 is when it's not horizontal, but it's got some up and some down. If we have a situation like that, let's draw a picture of this just really quickly. Let's keep it simple. So maybe instead of softball, I want to keep it a little simpler. Does anybody play soccer? Do we have any soccer players in here? All right, a few soccer players. So when you kick the soccer ball, like sometimes you're going to kick it like dribbling it, right? I'm not a soccer player, so I'm kind of out of my element, but I'm going to pretend like I know what I'm talking about. I like doing that sometimes. Right? Is dribbling a thing?
Yes.
Yes? Where it just kind of like goes along? Is that okay? I played soccer when I was like 6. But I wasn't good, and that was like the only year I played. So anyway, so like there's that. But then like if you're like going to give it a really big kick, right? Like it goes up and comes. Is that true? Yes? And generally it's going to start at ground level and it's going to go back to ground level. So it's something like, so if this is, whoa, that's supposed to be flat. That was not flat. Let me try again. That would not be a good soccer field. Okay, let's pretend it's flat. It's close enough. And here's my soccer ball. And it's got a trajectory that goes up and comes back down. Go ahead and draw that on your paper. So it's going to go up and come back down. Something like this. If that's the case, can you draw for me the initial velocity vector, a straight line vector that describes or points in the direction of the initial velocity? Once you've drawn that, check with your neighbor and see if they have the same picture you have, or the same arrow. Maggie, do you have an arrow drawn on your paper? Where does it go? Like that, right? Yeah, like that maybe? Yeah? Okay. What's different about this arrow from the cat falling off the table or the ball falling off the table or the really bad example of Anna trying to throw from center field? Yeah, it's not just going horizontally now, right? It's got some up and some out. So that means that when we set up our chart, we've got dx, vx, ax, dy, vy, AY, and T. And you may be looking at me like, you haven't told us anything else about the situation, Ms. Carveling. I know. This is more of kind of like just an example, like kind of a situation to think about. What things can you fill in right away? There are a couple of them that you can just fill in like without even thinking, right?
Y acceleration.
Y acceleration is what? Because it always is, right? What else can you for sure fill in?
The displacement of y is 0.
Whoa! Look at that. That's so cool. Like that's totally not what I expected to come out of your mouth. That made me really happy. She just said the displacement of the y is
0.
yeah. Look at that. The ball goes up and comes back down. High five for you. That's good. Yeah. Sweet. I like it. Is everybody okay with that? Do you see what just happened there? The ball goes up and comes back down. So it started here, and in the y, like we don't care about x stuff. In the y, it's as if the ball just goes straight up and straight back down. Kind of like that little girl who was throwing that apple up, you remember what we were talking about? Right? If she had caught it, same kind of deal. The displacement is 0. All right. Sweet. What else you got? Anything else that we can fill in for sure, no, like without even thinking a whole lot? There's one more thing.
Wait, AX?
AX. What should AX be, friends?
0.
It should be. I'm going to go ahead and label this just so that we can kind of talk about it. I'm going to call this case number 2. Okay? Case number 2 is where it goes up and comes back down. It has a displacement of 0 in the y. Now, often, not every time, but often when we have situations like this, they're looking for dx. Often. Because you know dy. Can we call vy 0 now? No. This is where that vector business that we did at the beginning of the chapter comes back in. Are you ready? It's not hard. You just got to think about it. So as long as you think about it, life is good. Take a look at this. We have got part of this velocity vector, the one that goes up at the funny angle. We can break that into components. Just like we did with the rodeo clown. If you remember the rodeo clown. Just like we did with, I don't remember, some Muppet that was going in a crazy direction. We can break it up into one part that goes like this. I'm going to call this Vx. This is my initial velocity. And I've got one part that goes like this. And anybody want to give a guess as to what I might call that piece? Oh, you guys are good. And probably we need to know some angle theta. Are you with me there? If I told you theta and I told you the initial velocity, can you find the x and y components? Yeah. Okay. Like if we were going to do the x component, well, the x component is what part of that triangle? The adjacent side. Does everybody see that? This is the hypotenuse. We have adjacent and hypotenuse. Which trig function do we want? Cosine. Yeah. So the cosine of theta would be Vx over Vi. We know what Vi is, though, so we can say that Vx would equal Vi times the cosine of theta. You see what happened there? Vx equals Vi cosine theta. I'm just multiplying by Vi on both sides. Pull it over here. With your table mate, or table mates, figure out what Vy would be. I bet you can do it. I believe in you. Go ahead and try. Which trig function do you want to use now? Sine, right? The sine of theta is equal to Vy over Vi. So Vy is equal to Vi sine theta. Is that okay? Okay. Then, look, you have everything in the y stuff except the t, so you can do the same kind of deal to find time. And then you can use that to move back up. So then it's just the same problem again, as we just did before. All right, are you ready to give it a shot? Is anybody stuck on this stuff? Yeah.
Would they give you like the initial velocity and or angle?
Yes. And Madison forgot to remind me to answer her question, so I'm going to answer that question in just a second too. All of the problems that you're going to do, that I'm going to ask you to do, they will give you Vi and theta. In the realm of all physics, you could be given dx and theta and asked to find Vi. I'm not going to make you do that, though. Does that make sense? The other piece of that, and this isn't even the answer to your question yet, usually I would tell you, anytime you're doing things for this class, if you want to review or you want more practice problems, to look in the textbook in those ugly brown boxes, and those are good questions. That is true except for this section. I would not recommend working through the brown box problems from this section, okay? They're doable, they're just really hard. I don't know why they wrote really, really hard problems for this stuff, but they're jerks and they did for some unknown reason. So I'm going to give you more practice problems to work on, okay? Yeah. Did you have a question, Cindy? Are you okay? Okay. All right, so I'm going to give you a practice problem to try. It's about a football situation. So it says a football. Oh, and then I forgot to answer. Madison, you've got to remind me to answer these questions.
Answer my question.
Answer my question. Let me answer her question real quick first, and then I will. Oh, wait. I wanted that. Sorry. I just wanted to remember to answer this question. Madison had asked me when we were working through this stuff, so this is back to Pelican, do I have to write this out again? Right? That's kind of what you're asking. Do I have to write this whole process out for time? Here's the answer. When you take your test, you will have your equation sheet, right? Your equation sheet has this equation on it. I want you to know how to get from here to the answer. If every single time you do a problem like this, you just start here, I guarantee that you will probably have a hard time coming back and forth when you actually need to. Okay? So I want you to start from here every time. If you're just doing practice problems, I'm never going to know. But I will expect to see this on problem sets and on homework and on tests. Does that make sense? Yeah.
Do you have to change the equation, or can you just solve for what you need to solve for with the original?
Do this first. And she's like, dang it. But the reason is because in case 2, if you just try and plug in numbers first, it gets really confusing. Because then you're writing 27 cosine 32, blah, blah. It just gets really messy. If you leave it like this, it's going to go a lot faster. It's going to be a lot easier to do. Okay? Okay. I want to know what that football problem was about. Well, let me tell you. Here it is. It says a football is cooked. That would be interesting and wrong. Kicked at an angle, I don't know, I must be getting hungry or something, of 37 degrees with a velocity of 20 meters per second. So they tell you both pieces, right? They tell you the angle and the velocity.
Basically football.
It's right, leather, right? Assume that the ball leaves the foot at the ground level. Ignore air resistance, ignore the rotation of the ball. You're probably like, I wasn't even going to include those anyways. But I got this from a higher level book that included that. So the question says to find the time and then how far away it hits the ground. So those are the 2 pieces that we've been doing every time. It will be a little different this time though. Okay? Draw the picture first, fill out your givens chart, and then give it a shot. Go, go, go. guys are so quiet. I find it so interesting.
Wait, so in our Gibbons chart, do we fill out VI as the hypotenuse?
So honestly, usually when I do this, I just figure out what Vx and Vy are.
Oh, okay.
If you want to write V maybe over to the left, you can do that. Like if that kind of helps you. Hold on just a second. I'm going to write that down real quick because I kind of like it.
Wait, so VI is different
Oops.
than VI and VX and VY?
So Vi is the hypotenuse. The Vx and Vy are the pieces, the components of it.
Okay.
Does that answer your question?
Yeah, because I know in the other problems that we did in the Gibbons chart, we always put VIX and VIY.
Yeah, I just get lazy. Honestly, because I don't ever have VFs, that's why. So those should be VIXs. Yeah.
Okay, but then the 20 for VI, that's different?
Yes. So that is this piece here, that's the hypotenuse. And then you need to break that into an X and Y piece.
Oh,
Yeah, yeah. Amy, did you have a question then?
I was just gonna tell you about the.
That I wrote it down wrong?
Yeah.
Thanks. I appreciate that. It's fantastic. Double check with your initial velocities even as you're going through to make sure you get those right.
If there's two T's, how do you
So we've done problems like that before.
use a quadratic?
So let me answer that question to everybody, but let me make sure everybody is here. Are we doing okay so far?
Yes.
You can see that it's kind of similar, but when you get here, it's a little bit different, right? The thing that goes to 0 is not the VIT anymore. Darn it. You have this is equal to 0. So now you can do the quadratic formula. You don't have to in order to solve this problem. How can you approach this without using the quadratic formula? Any ideas? Any thoughts?
Isn't it T squared at the end?
Oh, that should be T squared, yes. Yeah, sorry, that was my bad. We've done problems like this before. Perhaps.
Takes 0 time to teleports.
What's that?
Takes 0 time to teleports.
Wrong answer. Wrong answer.
If, like, we're doing an algebra,
You don't have to use the quadratic formula. You could, but it's not actually necessary in this question because one side is equal to 0.
yeah, so I was, okay. Would you take, since the change in y is
Mhm.
0,
Okay.
then negative vyt is equal to 1/2 AT squared.
Is that what you mean?
Yeah.
Okay. And then what?
And then divide both sides by t.
Yes. Yeah. So this is the thing, I mentioned this a while ago, and I told you not to tell the math people that we do it, right? Shh, it's a secret. But it makes our life okay. If we divide by t, then the math people say that loses a solution, but we don't care about the solution, so it doesn't matter. If we divide by t, then you're left with just one t. And then life is okay. You with me there? So if we divide by t on both sides, then you should be able to solve it pretty nicely. Is that okay? Yeah, go ahead.
How did you get it to be like negative
So Zach told me to subtract this to the other side. Since this was 0, it just moved over there.
So it becomes negative.
Yeah, exactly.